All right, I've muted you all again. Our next speaker is Matthias. Let me unmute Matthias. Where are you there? Hang on. Hi, Matthias. Okay. Can you share your screen, please?
Sure, let me try. So I'm assuming you can see my screen.
Yes, I can see it. So
great. Okay, thanks for the intro. So 15 minutes is a rather tough timeline. So I moved all the marketing slides to the end. Still, I would love to dedicate some time for the first slide, and this is for my today's Geo beer, which is a Welde #1 Slobby Pils. A proper Pilsner local to the Mannheim area, known for its very fancy bottle. So I think in those virtual times, you still have to appreciate the benefits of those physical traditions. Let's get to the topic for today. So to motivate my topic for today, I'll briefly describe a situation that I often found at customer sites. And this is, on the one hand, you have a data science department or business analytics department, and they have tons of data and doing like data science and analytics based on that. And the data science department may find out that statistically speaking, if you pick up a seashell and don't hold it to your ear, you can probably hear the ocean. And what is the reason for that? It's the location, simply because you're probably close to the ocean. And often they won't understand the actual reason for the correlations that they see and simply say either it's a crappy model or they simply don't understand it. On the other hand, behind a wall, well separated, you have the GIS department. And of course, the GIS department is preparing maps and also doing analytics. So you might have those maps where you see the site's users and they perfectly correlate to the subscribers of Martha Stewart's Living, and this perfectly correlates to the consumers of furry porn. So the implications to the business are clear. Of course, they're not, because all maps are essentially showing the population of the states in this case. Of course, I'm exaggerating a bit, but you get the point. On the one hand, you have the analytics side, not really knowing how to deal with location data. On the other hand, you have the GIS department, which knows how to deal with location data, but somehow sits in its silo. Of course, you can exchange that with any other department because like big corporations tend to have silos. At the end of the day, this is all about data, about different kinds of data. Of course, you have relational data, you have spatial data, and each data needs a special treatment, a special processing, and of course, expert knowledge. But at the end of the day, everything comes to a common goal, and this is you want to generate insights out of that data. So be that guy and just see that at the end of the day, all the different kinds of data need to get together in some place. And this is actually what I want to talk about today. So I tried to give it a catchy title. So I called it GIS Data is Open-Hearted, Don't Keep It Imprisoned in its own silo. And I'm going to talk about how a data management platform can actually help of, at least on a technical level, break down those silos. So you may be surprised to see SAP here, because for those of you who know SAP, there's a high chance that you don't know it in the GIS environment. And you may be surprised that SAP is doing GIS. Actually, we're not a GIS company. So what I usually tend to say is that the very core of our business is business data, processing of business data, and actually getting business processes in the software. We also build our own technology foundation actually to run those applications. And we see that actually to get a 360-degree view on our customers' data, we somehow also need to support the spatial dimension, and we somehow also have to have tools for advanced analytics. And where I see us as a team, so I'm leading the engineering team for SAP HANA Spatial, is somehow in that area here between the business and spatial data, maybe in that red triangle. So we're not a GIS company, but we want to support that dimension in order to get it into our data models so that our customers can actually leverage their GIS or their location data. Since we're not a GIS company, we integrate with the players out there that you would know, like for example, Esri, and actually integrate Esri software into our ecosystem and the other way around. So since I'm going to talk about machine learning and spatial today, just one very brief slide about how machine learning works for those of you who don't know. So in a nutshell and very simplified, you typically have dozens of data sources, and it may be multi-model data sources. So it may be relational data, maybe unstructured data, it may be graph data or spatial data. And somehow you have to get those data sources together and build a harmonized data set, which is a science in its own. Out of that harmonized data set, you typically build something which is called training data with enhanced features. So this is typically, at the end of the day, physically, a very wide table containing certain features which are the input of my machine learning model. So it's not rare that this is a table with like few thousand columns, for example, depending on the model you want to build. And each feature that you, or each column that you have in the table is actually describing one aspect of the observation that you have in your training data. Based on that training data, you train the machine learning model, which is a piece of code which essentially spits out a model at the end of the day. And the model can be anything. A model may be a complex SQL statement. So that may be how it really manifests. And at the end of the day, you got some predicted outcome. And the bad news is this is not a one-time task. You have to do that all over again, because any model that you create gets outdated. Data changes and the results are not as you would expect. And so you have to retrain it again. How do you now treat spatial data in machine learning models? So from my point of view, there's actually one generic approach to do that. This is, you have your machine learning model and you want to make it spatially aware. So what are the kinds of problems you have to deal with? Typically, machine learning models don't understand latitudes and longitudes. They don't understand spatial reference systems, and they don't know about proximity. How you get that knowledge into the model is that you actually abstract from the geospatial specifics by calculating spatial features and using, for example, spatial binning or clustering. So the whole idea is to really get rid of the spatial specifics and somehow encapsulate your spatial knowledge into features which are simple to understand by machine learning models, like categories or like numbers. So one good tool is spatial clustering. What is spatial clustering? Given a set of points, you actually want to group those points into meaningful clusters for generating either advanced insights or for generating visualization. So like if you have those points and you simply do a grid clustering, static grid clustering, you can see if you now aggregate the number of points per cluster that you have certain clusters where there are high density areas and you have other clusters where there are low density areas. That you can use to, for example, visualize something like a heat map, or you can also use it to actually reference to that area here as a high density area. So that area would have an ID, let's say it's 47, and you would say area 47 is a high density area. This is something you can deal with in a machine learning model. Short introduction to static spatial clustering. So they're actually, if you want to tessellate a plane into polygons of equal size length, you may have heard that there are only 3 ways to do that. So it's only triangles, squares, and hexagons. And what is the difference between them? This is actually, if you look at the triangulation, you got 3 different kinds of neighbors. For the rectangles, you have 2 different kinds of neighbors, so the diagonals and the non-diagonals. And for the hexagons, you have only 1 type of neighbor. If you're having, like for the squares, 2 types of neighbors, the thing you have to deal with in machine learning models is that if you're doing an analysis of a certain location with its neighbors, like for example, the difference in income of households, you always have to weight the different distances of the centers of the areas, which makes it very cumbersome to deal with that data. And that's the beauty about hexagonal clustering. All the neighbors have the same distance, and that's why it's especially suitable for machine learning models and for doing analytics. So I looked at one example where you actually have trajectories of cars, and trajectories are a list of latitude and longitude pairs. It's rather hard to handle by ML models because it's not only points, it's trajectories, and there are certain geospatial specifics like the spatial reference system. Now you can use a spatial engine or spatial calculations. In my case, this is the spatial engine of SAP HANA, to actually abstract from its specifics and apply a hexagonal binning. So you have measures aggregated per bin, and a location get referenced by an ID instead of latitude and longitude. And an ID is simply a category or a number to a machine learning model, so something very simple. Here in that picture, you, for example, see just the number of cars passing by. So to dig a bit more into that example and show you what I've played around with is there's some data available on Kaggle. Kaggle is a data science platform, also providing very neat data science data sets where you can simply like try technologies out. There's one data set with taxi trajectories of the city of Porto from the years 2013, 2014. I used SAP HANA Express, so which is the free version of SAP HANA, which you can simply download with its spatial engine to do the calculations. I used the HANA machine learning Python client to actually connect the logic that you have in the database with a Jupyter notebook. That means I can use a Jupyter notebook or I can use Python to remote control activities or processes that are going on in the database. So I can tell the database in Python to do a spatial calculation, and the actual calculation will not happen on my client, but in the database. And on top of that, I used GL. For those of you who haven't heard, so that's an open source visualization library developed by Uber, which also integrates very neat into Jupyter notebooks. The very details of these analysis you can read in the blogs that I have here. So if you search for SAP HANA Taxi Portal, you probably find it on Google. So one thing that I have looked at is, for example, to analyze the pickup locations of taxis over time. So I applied an hexagonal binning in the database. I applied a binning by time by looking at the hourly pickup rates per location. And everything has been prepared 100% in the database, and then the result has been fetched to Python, to the Jupyter notebook, to visualize it in GL. And GL has a nice functionality of really visualizing that over time. And like you can see here in that video, you see a proper rush hour pattern like you would expect. Some of you may have spotted already the airport in front of the city. And now we're getting a bit closer to Christmas, and you'll see that the pickups get a bit more calm over Christmas, which is now. And then towards New Year, it gets a bit more crowded, and afterwards back to its rush hour pattern. So that's some very basic analysis that you can do by just preparing the data the right way. So the next thing I've looked at is the actual relation between the pickups and the drop-offs of taxis. So which are trails that taxis would commonly use in that city. Of course, I've never been to Porto, so I simply don't know without the data. Again, I applied a hexagonal binning. This time I just visualized the centers of those hexagonal bins. That's why you don't see the hexagons on the screen. Prepared the data in the database and visualized it again with GL. So here you see that 3D visualization where you essentially see the center of the city. You see that there is a significant traffic to the airport, like you would expect from taxis. If you zoom in, you also see that there is significant traffic inside the city. Actually, the major routes are from the inner city train station to the airport, which is not surprising, but a confirmation that we somehow have a meaningful visualization here. Good. This is not yet machine learning, as you may have noticed. So it's just analytics, just preparing data the right way, visualizing it the right way. Now, we can also use the machine learning abilities that we have on our platform to actually build machine learning models upon that. So one thing I've tried is a simple regression model for predicting travel times. So given a certain start area, given a certain target area, and given a certain time, what will be the time that the taxi would approximately take? I used the automated predictive library that we have in SAP HANA, which is, if you're familiar with that, something like the citizen data scientist approach. So it's a library which more or less automatically fits your model to the data that you have. So you just have to say that it is a regression model, but you don't have to care about very specific lists, things like imputation of missing data. So the library will take care of that. You see here at the top, actually the screenshot from my Jupyter notebook, where you see that a certain ride, I think this is from the inner city train station to the airport, at 5 o'clock in the morning would take something like 960 seconds. And at 5 o'clock in the evening, it would take something like 1,300 seconds. If you compare that with Google Maps, which just have the data of all our Android phones, and we just have some data from taxis from 2013, it's actually not that bad. So we're in the right order of magnitude with that model. Of course, it's just simple, and maybe we're lucky that it's somehow correct. One other thing that I tried, very similar approach, this time the model itself is a bit more sophisticated, is to predict the destination of a taxi. So given a certain start area and given a certain time of the day and given a certain direction the taxi is heading to. So I left myself the privilege of seeing the first 5 points of the trajectory for the training data. Where will it approximately end? Like in a real world scenario, this could be helpful to the operator of taxis, because not every taxi driver immediately tells where he's going to. And they could simply predict at which point in time they have how many taxis in which part of the city. So here you see an example where a certain taxi starts at a certain point and drives to the west. And you see the probability distribution across the city. And here you see the same example, just at another time of the day, but same starting location where the taxi goes to the northeast. And you again see the probability distribution. For both probability distributions, you see that there's a high probability that the taxi is going to the center of the city, because there's always a high probability that the taxi is going to the center of the city. But you always also see that if you're going to the west in this case, that there's some probability that the taxi will go to the ocean side. And by the way, the cell that you have here with a green marker is the cell with the actual highest probability where the ride is going to end. For the other side, you see that if the taxi is going to the northeast, there's a low probability that you're going to the seaside, but there's a higher probability that you end up here in the northeast. And you see that the cell with the most predicted destination is the one over here, which is pretty cool. So how can a data management platform support you in getting results like these? For SAP HANA is an in-memory database, which offers a bit more than just the typical relational storage. That is, you have advanced analytical processing engines on the database. So you have support for spatial data. This is where my team is involved, or what my team develops. You have support for graph data. You have support for embedded machine learning. You can also use your TensorFlow models on the database level. You have some support for data integration, like for example, moving spatial data to the database, also other data. And you have some support for application development. So it's really a platform to develop your business application based on that. Specifically to SAP HANA Spatial, so what does the spatial engine of HANA offer? First of all, SAP is OGC member, so the spatial engine of HANA is OGC compliant. It offers the functionalities that you would expect from an OGC database. We're working with Esri, and SAP HANA on-premise and in the cloud is a certified Esri geodatabase to use with ArcGIS Pro or Insights or the portal. And how does it typically look, or how do our deployments typically look on customer side? That is, you have on the right side the typical SAP applications that you would know, like you have your ERP, you have your analytics software running on the database, and you may have some custom apps just talking to the business database. And on the other hand, you have the GIS world. So you have Esri like Insights Pro, the portal, Enterprise Server, which is working with the Enterprise Geodatabase in HANA, which may be a different schema just for your geodata. And then you have all the different kinds of engines like spatial, predictive, graph, or the document store to actually seamlessly get together your business data with your spatial data and have a common reporting. And just for sake of completeness, because that's also in the middle, I want to mention, we of course also have a plugin for GeoServer where you also can connect other GIS software, open source GIS software. So if that short overview got you curious, there's some links which you can follow up. I think the most interesting one is bit.ly/HANA Spatial. This is a blog where a colleague of mine just gathered from some resources like YouTube videos, what you actually can do with spatial data in SAP environments. Of course, there's also the link to HANA Express, which is the version of HANA which you can download for free, and the reference of our spatial functions. And with that, I'd like to thank you for the time. I think I'm almost on time. You don't have to drag me from the stage. That's good.